In this lecture, we're going to see that it is possible to manage arrays through unique pointers. And the syntax to do that is slightly confusing. It is what you see here. We are using auto type deduction to simplify this a little bit. But you say std unique pointer, and then you specify that the unique pointer is going to be pointing to an array of objects here. And in this case, it is an array of dog objects. After that, you put a pair of parentheses in place. And inside, you're going to call the new operator and set up an array on the heap. And this is how you do this. Once you do this, you can really use this array like you use any other. For example, we can loop through the array, printing the information about each dog object. And you see we are using rptr here as a regular array. And this is going to work. This is how you use this syntax here. Another thing you should know is that you can also use make unique to do the same thing, and the syntax is what you see here. For example, we can say rptr equals to std make unique. We say dog pointer, and we specify that we have 3 dog objects inside. But once we do this, we can't initialize individual elements. And if you try to do that like we do in the 2 lines following here, you're going to get a compiler error. The syntax is not supported yet. But once you have the dog object set up, you can really do whatever you want with them. For example, you can print information about each dog object. You can change the information in each dog. For example, you can use setters and getters and do all kinds of crazy things. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is unique pointers and arrays. We're going to grab our template files pretty quick. Let's do that. And we're going to put them in place. And another thing we want to do is to steal the dog class from the previous lecture, because we don't want to set that up here. We can just reuse what we had in the last few lectures. So I am going to put this in, and I am going to open this little guy in Visual Studio Code. This is going to give us a project that is slightly ready to use. So we're going to include the memory header because we want to use smart pointers, and we are going to clean up a little bit, remove whatever we don't need here. And before we look at smart pointers, let's remind ourselves of how we work with arrays without using smart pointers. Okay, here we have an array allocated on the stack, and it is a dog array. It's going to contain 3 dogs, and we have dog 1, dog 2, and dog 3, and we can loop through this array, printing information about each dog. So let's look at the dog class and remind ourselves of how it is. So this is the setup here. If you need to look at it, take a good look here. Here is the implementation. And the print information function is just going to print information about the dog. It's going to print the dog name, and we're going to see it printed out on the console. So we're going to be looping through this array, printing dog 1, dog 2, and dog 3. And that's what we're going to see. Let's run this. We're going to pass this through GCC. You are going to see that we have a problem. And what problem do we have? We didn't include the dog class. Let's do that. We're going to include that. And we're going to build again. Sorry for this. Okay, you see the build is good. Now we can bring up a terminal, a PowerShell window. Let's do that. And we can clear and run Rooster. We should see the constructors for our dog called as we set up this array here. And we're going to loop through the array, printing each dog name. And once we are done printing, the array is going to go out of scope, and these guys are going to be destroyed. That's what we see here. Okay, to really make this super clear, let's make sure that we are in the main function scope, and we're going to say done. And we're going to build again with GCC. The build is going to be good as you see here. We're going to clear and run Rooster. Now we're going to see that the destructors are going to be called once we hit the ending curly brace in the nested scope here. And after that, we're going to say done. That's what we see in our output here. But this is not what we really want. We're going to comment this out, and let's go on top and do that. Another thing we can do is allocate our array on the heap, and we're going to put in the code to try and play with that. Let's uncomment the code here. Okay, we have an array allocated on the heap, and the syntax to do that is what you see here. I think we can remove all this clutter on top here because it's just going to give us noise output. We don't want that. We're going to set up a dog array. It's going to be dynamically allocated on the heap because we see the new operator here. And we're going to initialize those with data here, dog5, dog6, dog6. That's going to do. We're going to loop through the array. And after you use the array, you have to remember to release the memory. If you don't release the memory, you're not going to see the dog objects here destroyed. Let's build and show you this. The build is good. We can clear and run Rooster. This is exactly the same thing we saw before. We are going to set up the array. We're going to loop through the array, and then we're going to release the memory. And after that, we're going to hit the end of the nested scope here, and we're going to say done. This is what we see here. But notice what happens if we don't call the delete operator to release the memory in our dynamic array here. Let's build and show you that. We're going to pass this through GCC. And the build is good. We're going to clear and run Rooster. You're going to see that we are allocating memory. The constructors are called. We're going to loop through the array, but we're going to be done without releasing the memory here, and this is really bad. If the code here was split across multiple files and it is really complicated to keep track of this pointer, you may forget to call delete on your array here, and this is really bad. A better way to do this is to use smart pointers and let the array be released when the unique pointer goes out of scope. We're going to comment out and see how we can do that. So let's make sure this is commented out. Okay, so let's go down and show you that. We're going to put in the code to play with that, and we're going to close our terminal here. We don't want that. And we are going to look at the code here. So we have an array allocated on the heap using unique pointers. And again, the syntax is what you see here. If you wanted, you could say this is a unique pointer to a dog array, and you could do something like this. Let's make sure we say this here. I think the syntax here would work, but this is really verbose, and no one really wants to type all these things here. So that's why we use auto type deduction here to let the compiler deduce the type for us. And this is going to just let us type auto, and this is going to be easier to deal with. So we have a unique pointer, which is pointing to a dog array, and we're going to initialize our dog array with data. Here we have 3 dog objects. We're going to set up the array dynamically using the new operator here, and we're going to put in our data. This is going to work. If we have this set up and loop through the array, we're going to see that the information is going to be printed out. But the important thing I want you to see here is that the destructors are going to be called automatically when this unique pointer here goes out of scope. And this is really important for you to see and understand. We're going to remove all this clutter on top here, and we're going to build. We're going to pass this through GCC. You're going to see that the build is good. Let's see if we have any PowerShell window. We don't. We're going to bring up a new one. We're going to clear and run Rooster. And you're going to see that this is really what we expect. We have 3 dog objects constructed as part of these new calls here to build our dynamic array, which is going to be managed by the unique pointer called rptr here. And we're going to loop through the array. We're going to say for size t, we're going to start from 0. We're going to keep incrementing. And we're going to be calling the printful function at each element in the array at whatever index we are at in our loop here. And this is going to work. One thing you need to be careful about is that if you use make unique, you can do something like this. For example, we can uncomment this line here, and this is going to work, but you can't initialize individual elements. So for example here, if we loop through the array, we're going to be printing information, and we're going to be using default constructed dog objects put in our array here. If we go in our dog object, we're going to see that the dog object is going to be default constructed with the name Puffy inside. So let's build and run and see what we have inside. We should be printing Puffy, Puffy, Puffy. Let's build. So the build is going to be good as you see here. Let's bring up our PowerShell window, and we're going to clear and run Rooster. You're going to see that we say Puffy, 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 because we are calling default constructors. And you see that the destructors for these dogs are going to be called. And then we're going to say done once we hit the scope for the main function here. I really want you to see this. One thing you cannot do is initialize individual dog objects when you use the make unique syntax. This is not supported yet in modern versions of C++. If you try to do this, you're going to get a compiler error because it is not supported. Let's build and show you the compiler error. Okay, build finished with errors, and really you can't initialize when you use the make unique syntax. This is something you need to be aware of. Another thing you can't do is even use braced initialization, because I think some of you are going to think, what could happen if we do something like this? The answer is, this is not going to work, because make unique can't really work to initialize individual objects in your initializer here. If we try to build this, we're going to also get a compiler error, which is weird and confusing, but know the reason for that compiler error, and it is what you see here. You can't really do this. The only way to use make unique and set up an array of dog object managed by a unique pointer is the syntax you see here. You just specify the number of objects you have in your array, and this is going to work just fine. If we build and run, okay, we're going to see that the build is good, and if we run our program, we can clear and run Rooster. This is going to work just fine, so make sure you understand this. This is really all I had to share in this lecture. I hope you found it interesting. And this closes our exploration of unique pointers. Please make sure you use smart pointers if you want automatic memory management and you want for your objects to be automatically released when the name you are using to manage those objects is going out of scope. Smart pointers are really good in that regard. We are going to stop here in this lecture. The next one we're going to learn about shared pointers. Go ahead and finish up here and meet me there.